Okay, these three individual displacements must add together to get a total displacement. So if I label these things accordingly, I've got 40 meters north, which I'm going to call displacement 1, 10 meters east, which I'm going to call displacement 2, and 40 meters west, which I'm going to call displacement 3. And we're trying to add those three vectors together to get my total or my resultant displacement. So when you add vectors together, you have to use tip to tail. So let's see how this looks. If we do it in the order presented, I get 40 meters north. There's vector 1, that's D1. And at the tip of D1, I'm going to start D2. 10 meters to the east will be a smaller vector to the east, like this. So that little guy is 10 meters. And then at the tip of this one, and I'm just going to offset a little bit so we can see it, I'm going to then continue my diagram 40 meters west, which will look like this. There's 10, 20, 30, 40 meters west, like that. And that would be D3. So those three vectors all add together tip to tail, and we're trying to find the resultant, which will be in that gap. So my resultant, if I put it in red, will look like this. From start towards finish, that will be D total. We're trying to figure out the value of that pink line. Well, we can simplify this. Notice I've got two vectors here that are parallel to each other. 10 meters east and 40 meters west. You can see them on the diagram. 10 meters is to the right, 40 meters is to the left, and they partially cancel each other off to get a 30-meter vector that's towards the west. So I could reimagine my drawing a lot more simply if I simply just go 40 meters north, and instead of having these other two vectors, I've simplified them into one single vector that's 30 meters towards the west, like that. And that's a much easier triangle to solve. It'll give me the same pink line. So points from the start of my diagram down here towards the finish. So this is still what we're looking for, D total. But now it's simplified so I can quickly use Pythagoras. So with Pythagoras, we know that a squared plus b squared equals c squared. So we're trying to find the hypotenuse, which is d total. So I'm going to end up with 30 squared plus 40 squared. It's going to give me d total all squared. And when I solve that, I get d total equal to 50 meters. Now we need a direction. So if I look down here and call this theta, I can use any of my trig functions because I know all three sides, but I always recommend using your original numbers. That way you know you haven't made a mistake yet. So if I use the 30 and the 40 is opposite to theta and the 40 is adjacent. So if I use tan theta, as long as I've got a right triangle, which I do, I can put this together and solve for theta. So to find theta, it's inverse tan of 30 over 40. And when you put that into your calculator, make sure you're in degree mode, you get 37 degrees. And that would be swinging to the west of the north line. So west of north. So my full answer, my total displacement, is 50 meters at 37 degrees west of north.